Junior Science Tutoring. So, in the last class, we have started the chapter Light, Reflection and Refraction. So, we have discussed the different laws of reflection, the type of mirrors, plane mirrors and spherical mirrors, and the different terms regarding the spherical mirrors such as pole, center of curvature, radius of curvatures, all those things we have seen. So today in this session we'll see the representation of images formed by spherical mirrors by using ray diagrams. How we can represent the light rays in the process of reflection. So first of all, we'll check how the light rays are getting reflected in a concave mirror. Okay, so the first thing, let's draw a concave mirror. Concave mirror is the mirror which have the reflecting surface curved inwards. So this is a concave mirror. Then we have the principal axis like this. We have the center of curvature C, then the pole P. All those things we have seen in the last class. So suppose the light ray is coming parallel to the principal axis and getting incident on the mirror like this. So the incident light ray is coming parallel to the principal axis and striking on the mirror like this. So what will happen to this light ray after reflection? So once the light ray gets incident on the mirror, it gets reflected through the focus. Okay, here if this is the focus, then this light ray will be getting reflected like this. Through the principal focus it gets reflected. So this is the first representation. That is, if the light ray is coming parallel to the principal axis, then the reflected ray will be coming or passing through the principal focus. Okay, then the next case. So the second case, let's draw another concave mirror. Then again we have this principal axis, then the center of curvature C, the pole P, and we have the focus F here. So suppose the light ray is coming through the principal axis and striking on the mirror. So like this, light ray incident on the mirror like this, that is passing through the principal focus. How it will get reflected? Once the light ray get reflected, in this case the light ray will get reflected and pass or emerges parallel to the principal axis like this. The ray will get reflected like this. So if the light ray is coming parallel to the principal axis, then it will reflected through the principal focus, and if it is incident through the principal focus, it will emerge parallel to the principal axis. So I think both these are clear to you. Then the next case, again we'll draw a concave mirror like this. Then we have the principal axis, the center of curvature C, pole P, we have a focus here. Okay, like this. The third case is if the light ray is incident on the mirror passing through the center of curvature. If the light ray is coming like this, passing through the center of curvature like this, then the reflected light ray will follow the same path as the incident ray. So the reflected light ray follow the same path, that is reflected through the center of curvature itself. Okay, that's the third case. And next, the fourth and the last one, that is concave mirror. We have the principal focus, the center of curvature C, the point P, and we have a focus here F. Suppose the light ray is coming and incident like this at an angle I. Then in this case, the reflected light ray will follow the path like this at the same angle. That is, the incident angle and the reflected angle will be the same. I will be equal to R. That is, if the light ray is incident on the ball at an angle I, then the reflected ray will also have an angle equal to the incident angle. Okay, hope these four representations are clear to you. Next we will see this same representation in the case of convex mirror. Let's see the first representation in case of a convex mirror. So in case of a convex mirror, the reflecting surface is curved outwards. That is like this. So this is the reflecting surface. So we have the principal axis like this, and this is the center of curvature C. Here we have the pole P and the focus F. So the first case is if the light ray is incident on the mirror passing parallel to the principal axis. Then in this case, the reflected ray will be like this. It's seen like diverging from the principal focus. But you can see that if we extrapolate this light ray, we can see that this is passing through the principal focus. So in case of a convex mirror, we get a virtual image. That is, the image is formed at the back side of the mirror. So that is the difference between a concave mirror and a convex mirror. Okay, this is the first case. Then the next case, we have a convex mirror like this. Then the principal axis, we have the center of curvature here, then the focus F, then the pole P. So what was the next? The incident ray is coming or passing through the focus. So this is the focus. So the light ray should be coming like this, passing through the focus. But this is the back side of the mirror. So once it hit the mirror like this, here it gets reflected parallel to the principal axis like this. Okay, so the next case is incident ray passing through the principal focus. Once it hit the mirror like this, here it gets emerged parallel to the principal axis. And the third one, what is that? We have a, sorry, not this, we have a convex mirror, then again the center of curvature, focus, then the pole P. Okay, so next case is the incident ray passing through the center of curvature. So here this is the center of curvature. Okay, so the ray will be coming like this, passing through the center of curvature, but once it hit the mirror like this here, it gets reflected back in the same path, following the same path. All these things are similar to the concave mirror. The only difference is the image is formed at the back of the convex mirror. Okay, the image is virtual. So once the incident ray hits the mirror here, it gets reflected back in the same path. Okay. We have a convex, we have a convex mirror, then the principal axis, center of curvature C, point P, then the focus F. So here, if the incident angle is incident at the pole at an angle I, then the reflected angle will be like this, with an angle equal to the incident angle. So if the incident ray is coming like this and hits the mirror at pole, making an angle I, then it gets reflected through this path with the reflected angle equal to the incident angle. So that's all for today. Hope you understand both the representations, both in case of convex mirror as well as in concave mirror. If you have any doubt regarding this, please comment, and if you like the video, please like, share and subscribe and click on to the bell icon.